with this video, I'm going to show you how I can read a pin. In this specific case, I'm going to read PB0 from the AtMega328P, and then I want to write data to other pins depending on what the value is on PB0. So for this specific video, I just connected, I created a Proteus project just to show you, but I could have done that also on hardware. So basically what will happen is I've got an LED through a resistor connected to PB5. It's actually on your Arduino board, it is already connected, but let's have a look at this. For instance, PB5, this LED, I want this LED to be off if the input to PB0 is a 0 as it is now, and I want PB7 to be on, the LED to be on again if I get a 0 on PB0. And if I open the switch, that means PB0 becomes a high, it's a 1. And then what I want to happen is that this LED connected to PB5 must be on, and the one connected to PB7 should be off. So it's just a little bit playing around with what's happening on the input. What's happening on the input should actually be reflected on PB5. Yeah, but let's have a look at the program and then decide what we will do. So if I go to my program in Atmel Studio, the first thing I've done here, of course you must always include the header file, and then in the data direction register I made PB5 and PB7 ones, which means they become outputs. And then on this step is actually not necessary. I'm just showing you just to avoid confusion, because at startup your DDR-B register will all be zeros, meaning that they will all be inputs in any case. So so this step is actually not required, this statement here. But let's just say, but if you do it, there's nothing wrong in doing it. So, but let's do it quickly and say, basically what I'm doing here is I make sure that pin 0 of port B becomes a 0, which is making that an input. So, but as I've said, it's not really necessary to include this. Then what I've done here is I am testing what is happening. This is the way to test on port B. But we've seen in previous videos that if I want to read something in, whatever happens on the outside of the microcontroller, I will read on pin B. So this is why I'm ANDing bit number 0 of PB0 with this value. So I'm testing basically PB0 by doing that. If bit PB0 is a 1, then I will execute this section of, or these two statements. If it is a 0, I will execute those two statements. So if it should happen, I've tested this, and if it should happen that it's a 1, PB0, then PB5 must be made high with this statement here. And it will switch on the LED connected to PB5. And at the same time, it will also make sure that PB7, this is port B, bit number 7, will definitely be made a 0, switching it off. So yeah, if PB0, yeah, is testing a 1, switch on PB5 and off PB7. If it should happen that PB0 is a 0, then I want PB7 to become a 1 and PB5 to become a 0. In other words, switch off. So in here PB5 will be switched off, and here PB7 will be switched on. And this is the program. So if we go back to the Proteus design, which is this one, it's exactly happening like that. If the switch is open, I get this high through this resistance on PB0, and that indicates if this is high on PB0, I want PB5 to be a high out and switching on the LED. And at the same time, PB7 must be a 0, switching off this LED. If the switch is closed, that means the 0 from ground is going into PB0, and if that happens, I want the diode connected here to PB5 to be off, or a low value to come out there, and PB7 to switch on, which is happening at this stage. So yes, it is happening according to what I've done in my program, and now in this video, in other words, I've read a specific pin condition and I've given some outputs according to that input pin. And let's continue in further videos and have a look at more ways to manipulate inputs, outputs, etc. Thank you.